on-off, it's because the half-life is so fast, and we're not talking about complicated things that we have to worry about high-end or low-end. We just have to respond and have alerts. And so in doing that, you're talking about pretty simple software, what you need to know.
Yeah, if you can make an Angry Bird app, you could probably do this, right?
Hmm?
If you can make an Angry Bird app, you could probably do this, right?
Yeah. What's that?
Yeah, I think Angry Birds,
So,
the game on.
it's a game where you fire these things out of a slingshot,
Angry
and it's
Birds.
got different trajectories on it, and it will land it at specific spots depending on how much force you pull back with and how high you shoot it and that sort of thing.
Same
Some
thing.
good
And it's same
vectors.
kinds of equations, I'm sure, behind all of it.
It's all the same now, yeah.
When I talked to Mr. Shockley, he was saying using PC would be easier for some reason than using a Mac. I don't know why.
But your first assumption should be that you're gonna save half the oxygen that's currently used.
I'm sure there's an easy way to find out how much
Yes,
oxygen is used at a hospital.
So that's the first question, is how much does a big hospital spend for oxygen? And, you know, if the number is a couple million a year, and it probably is, I wouldn't be surprised if it was six figures.
I know what patient charges are,
Well,
but they're not
That's an
real.
upcharge, isn't it?
Oh, yeah.
Well, they're not gonna go down, don't worry, they won't all over the place.
No, that's technically.
Just make it
Yeah,
work.
that's technically.
But but if you just had a ballpark, I mean, if the cost of oxygen is $50,000 a year for a big hospital, your $2,000
Makes it
control
worthwhile.
circuit is not gonna fly, because it's not saving any money. You drop 25,000, you pay for a few machines. They'll have problems. It'll be 10 years before they're regulated to a point where they're small enough that they can be on that home oxygen, which would be a big savings if it would save 50% of the home oxygen. Because if it were to respond to the person walking, increase oxygen and cut back when they're not, then the tank.
That would save, and on other equipment, you know, the ventilators and things like that in the hospital, they've got computers in there that do things that are equally sophisticated. I wonder why no one's ever done this.
That's exactly what I was gonna
Yeah.
ask a minute ago, is that you did this complex thing with the insulin. Why has nobody done this? Why hasn't an anesthesiologist done this? Why hasn't a pulmonologist done this?
They don't, doctors don't
You don't think that way?
think that way, this way. They don't, I didn't think this way. The only reason I did is because I happen to have the right training, and I happen to be asked to improve care in a situation, and when I finished my paper protocol, the nurses hated me, but I had spent hours, free time, teaching them how to use this 3 or 4 page table,
And then
and all we did was get the sugar halfway there. And it needed to be a whole lot more sophisticated, and they were starting to rebel at that level. And then what happened the first night, and for the first week, I actually I carried a computer with me all the time, and I got all the readings and did simultaneous readings, and just evaluated whether that response was a reasonable response. Was the computer responding? They would call the sugars to me and tell me what the computer said. I'd check, see if that's what mine said,
yeah.
and then look to see whether that patient's trend was the right dose for that patient. And then the secret turned me up, that told me this was worth something, is the first night they called up after about 3 or 4 hours, about midnight, they called up on the first patient. We're doing one patient at night. And they said, oh, this is so easy. Can we put the other 2 patients that have sugar on?
Oh, serious.
That have high sugars. They wanted to use it as opposed to the other method. And I said, only if you do the sugars at the same time, because I didn't want to be awake 24/7 for a whole week, because I was trying to figure out whether the Excel spreadsheet was working, because I didn't have all the safety stuff built in. Here, as long as you have a way of increasing the oxygen and an alarm when you're not meeting your goal, the risks are much less. You probably can get this in.
There's, as kind of an aside, you know, you talk about safety and outcome. there is such a thing as oxygen toxicity. But nobody knows what the threshold for that is.
And isn't it gonna be different?
The textbooks say that once the fraction of inhaled oxygen exceeds 60%, you increase risk for oxygen toxicity.
Onto the tissue.
Yeah.
To the
An
lungs.
idea there is with the extra oxygen, you get free radicals and it injures tissue. And there are some people, and again, this is unproven, that think that we over-oxygenate people all the time in the hospital because we're more concerned about the opposite problem of not getting enough, that we over-treat them, and maybe that over-treatment is potentially
It sounds like
harmful.
marketing.
So
Now,
why,
that'd be a very difficult question to research and get at.
that would be an
It
extension.
would take a really
Yeah.
large
Never
study,
seen yours.
and you'd have to have something like this that could very tightly control oxygen, and then do it, run a randomized controlled trial where you had one group that had traditional oxygen therapy and one group that had this type of therapy, and look at outcomes. And people have done that with other things in ventilation. It takes thousands of patients and years to do. But if you start to think about some of that, then that's where it can go.
And that's the way to prove it, that it's clinically efficient to do. If you save money at the hospital, you can always get, you can often get things through the back door into hospitals, or end up getting to the product side by saving money.
Right.
Delivering the same care by saving money. Interesting.
Yeah, the more you think about this, the more the potential it has. It's really complicated.
And you would need
More than-
you would need to test a patient or two. Just once you got the thing, first of all, it's a project to get it to work.
Yeah.
But once you get it to work, you could probably test it on one or two patients who have lung disease, who desaturate when they exercise.
My dad was talking about that in the.
I got all kinds of those. We can get
I was
those.
gonna say, that's what I'm saying. There's a lot of people like
We
that.
can get those.
And you can get them to just try oxygen. And as long as there's a physician there who's gonna intervene if the machine's not working right, it's a easy.
You have to have certain things set up to make sure nothing, well, if something happens, that we can fix it.
Yeah, right. It's not left alone. But you got a long ways to go. You gotta
Yeah,
get,
wow.
thinking about your critical pathways, the math is pretty straightforward. You may not see it, but it's pretty straightforward. Your critical pathways are deciding how to feed back and what to feed back, and then how to get it into a mechanical, how to get it from electronic to a mechanical alteration and dose. And there's multiple ways of doing it. I just don't know the right answer. I'd have to look stuff up. I think I'll take a look.
I think we need to sit down and be realistic for their time frame.
Well, right, so that's.
You know?
It was January 31st.
Well-
Obstacles and.
Say that by, I'm gonna turn this off.